which means that if you make mistakes, you actually don't get to compile the project. So if your template generates wrong code, it won't compile. It won't break when you make a mistake, when your client is using the app, which is the worst, right? You don't want to crash during the use of the application. You'd rather have the build time errors. And Sorcery actually allows it to very easily create a system when you get build time errors every time you mistake something. And what's nice about Sorcery is that it allows you to real-time program your templates. So unlike Swift, when you change code and you have to wait minutes in bigger projects to see whether your code actually worked, with Sorcery, you can just type. And every time you save your file, you will see the results generated in real time. And honestly, this is how programming should look like. If we can, like playgrounds, even playgrounds are not as fast as this kind of thing. But this is the direction I think we should be going at in the industry, not in iOS, but in general programming. I think this is very convenient. So here I'm inspecting a New York Times code base 2 years ago, and we already had hundreds of types. And so this, as you can see, Sorcery can generate arbitrary artifacts. It doesn't have to be Swift code. I know people that actually generate Objective-C from Swift. So if they have a project that has to support Objective-C interfaces, they have templates that actually translate one to the other. That can happen. I don't actually do that, but it works. One of the nice things that Sorcery adds on top of the scanning abilities is it introduces supports for annotations. If you ever work with Java or Rust, you know that there are ways to attribute both variables and types with meta information. So for example, in Sorcery basically introduces that. So you just add a comment and you do Sorcery : and then you can provide attributes for your types or your variables. And that can be as simple as just saying, okay, skip this variable when you're doing persistence, or like this is the JSON key for saving this person. Like you can actually add like as many properties as you want to each type, each variable, and this can be used in your templates. So this is very convenient because when I created Sorcery, things like derived implementations of equality, hashable, and codable did not exist. That was actually one of the reasons they built it, because so many people were using code generation to get those things, because obviously those things should have existed from the day one because it's very simple to do. The problem with their implementation, and I actually know they did it because of that, because I know people at Apple that use Sorcery, and I actually got like Git paths for Sorcery from people at Apple because they cannot do it publicly. But that was pretty cool and completely surprising. But they did send me a couple of bug fixes. And basically, the problem with their implementation is that they cater to the generate case, the 95%, which means that if you are OK with the default implementation, you can use it. So if you want your equality to be every single property in your type compared against the same properties in a different instance, that's fine. But if you have transient properties that you don't want to compare because they don't actually matter for equality, or they don't matter for persistence, then you have to, the moment you decide that, you basically have to skip it, right? Or in case of Codable, like you have to add the keys that you want to persist, and then you can skip that specific key. But then the problem that generates it, you have to maintain all of those things by hand the moment you make the decision. So if you add a new variable, you need to remember to add a new key value if you want that variable to be persistent. If you want to have equality by hand, then you have to make sure that you also add those checks in the functions, right, in the equality, in the hashing. And this is originally the problem that I faced, because writing those things is very easy, but maintaining them is very problematic. And a lot of people forget to update them. And then you have problems at runtime, like your cache misses, and you have different layouts because you cache the height, but now your object has more properties. Not all of them are compared, and now you have bugs that only appear in production. So that's very not convenient. And the other feature that Sorcery has is inline code generation, because by default, Sorcery will generate your Swift code or any other artifacts in a file related to your template name. So if your template name is autoequality.stencil, you will have autoequality.generated.swift. But that doesn't work for every use case, because you can have required initializers. And if you use required initializers in Swift, then you would know that those have to go into the file when you define it. You have the definition of the type, it has to appear there. So for that, there is a Sorcery inline support. And basically the way it works is you just add sorcery inline auto in your template, and sorcery will automatically add this code at the end of my type definition. So it will change your actual source code. So we use this for NS coding, for example, because they have required initializers. Very simple, very convenient. How do you integrate sorcery? You have a build phase for your project that runs before the compilation. There's a lot of common templates distributed with it. And when you're working on new templates, you definitely want to leverage a daemon mode to get that real-time feedback, so it's very easy to understand and use. And you don't have to worry about build times, because sorcery not only has fast parsing that's multi-threaded, it also has extensive caching, and it has very negligible cost in comparison to your actual Swift build times. So for New York Times, it's less than a second, and this is a huge project. Most iOS projects are much smaller. And so I would be very surprised if you actually noticed that you added sorcery to your build. So how do you write custom templates using Stencil? So there are only a couple of basics that you want to know. Basically, there is a tag to render a variable, which is just the first one. You can also create local variables in your templates, which make it convenient to reuse code. You can create functions using the macro tag, and you can call that function using the call tag. So those are 4 basic operations that you need for 95% of your templates. There are obviously for loops, which are very simple. But what's more important for you will be the way to access the AST information in your project. So sorcery defines a couple of top-level objects you can access in your templates. And you can do things like types implementing specific protocol. You can do types inheriting from something. And the nice thing about this is, so this is the basic to access the array, but you can apply multiple filters on arrays that you have. So for example, you can do types.implementing protocol name, pipe, like you would do in Bash, and then you can specify enum, or you can specify struct. And that means that that array will now contain only structures or only enums. And you can pipe together as many filters as you want. We have a lot of filters. For example, the annotation feature that I mentioned, there's a filter called annotated, and there's a reverse of it, which is not annotated. And then so you can do types implementing protocol name, pipe enums, pipe not annotated, skip, persistence, and then you have this array that you can use code to tweak. And you can check variables, you can check annotations. There's a full documentation on GitHub that you can access. And honestly, those 8 items, like so 4 Stencil basics, 4 AST plus the for loop format, which is the same as in Swift, basically, that is kind of all that you need to start building custom templates. So there is a simple example I'll give you. I wrote this article about using protocol composition for a more convenient dependency injection approach. So let's say I have my application. In my application, I have a bunch of top-level dependencies. So I'm talking about things that are pretty much singletons in my application. So for example, I have one API client for my servers. I have one content coordinator, which basically, just gathers some data and deals with caching. And then I have image provider. So those are my 3 top-level dependencies. And now I want to have protocol for each of those dependencies, because that will allow me to do something like this. So rather than having each object that I have in my project, each actor in my project, or each view controller, view, whatever you want to call it, view model, depending on your architecture, normally you would inject each of those dependencies separately, which is very nice, but there's a problem. If I have a type, let's say a view controller, that starts with just requiring content coordinator. So I create a variable content coordinator, and then I inject it using init injection or setter injection, preferably init, since it can be let and immutable then. Now, the problem is, a lot of the times, as the project grows, you actually need more dependencies. Obviously, if you start to need too many, probably a reason to split that class into multiple classes that do just single thing. But being pragmatic, you usually end up having more than one dependency. And now every time you add a dependency, you have to modify your init, you have to add new variable, and the bigger issue is you have to modify every part of a project when you create that object, all right? Because unless you use dependency injection containers, which I don't like because I don't like globally accessible singletons too much. So The problem with that approach is now you have to change, whenever you add a single dependency, you have to go and change that code. And the other thing is your view controllers or your view models are usually a bit larger than this. So the readability of what are the actual dependencies of this object are not that simple. With my approach, you just declare a type alias, which is called dependencies, and then you use that protocol that you created before. So for each dependency, you have has something, right? So has image provider or has network client. And you use protocol composition to join them together. So if I create a view controller first and its type alias dependencies has network client, so it only has one dependency, and then I create an initializer, I just index the dependencies object, right? And in my case, I use flow coordinators, so my flow coordinator will have that basic structure containing all those dependencies. But my child object, which is the view controller, will only have access to the actual dependency it needs. So just a single object. Now, this is very nice to use. I have an article about this, which explains much better than I can right now. But the basic problem here is that for every single dependency, I have to create this protocol has API client, and then I also have to add to the struct app dependencies, I have to add conformance to this protocol, right? So there's not only the has API client, which is already 3 lines, but also the 4th line, which is actually defining that support, which is, I don't like writing code that can be generated. So I can just do for each type implementing that specific protocol, which is the auto properties. I can define, first I'm going to mark it because if there are more types, I want to know where I'm in the file. But then I'm going to generate all of that boilerplate. So I'm going to generate an extension, I'm going to generate a new protocol, and then I'm going to generate conformance to that protocol. And the nice thing about using Sorcery to do it is whenever I add a new dependency, all of this will regenerate automatically. So this is the code that I won't have to write by hand. I won't have to maintain, which is very nice. And as you can see, it's very simple. So for example, I just iterate over the type, over all the variables in that specific type. Then I create a new local variable called protocol name, because that protocol name I need twice. I need it for the definition, and then I need it for conformance. So I don't want to repeat the title case filter. I'm just gonna reuse that variable, which is very simple. And the nice thing is on the right, I can see the results. So even if you don't know Stencil, even if you don't know the AST, as you write, you will get the results immediately, which is very good way to learn that specific feature. So this is as simple as having a couple of lines, and then everything in this project, whenever I need that protocols, I just add a conformance to auto properties, and then I get all the code for free, which is very convenient. That's pretty much it, right? So another example is in the New York Times, we have events tracking. This is more for like performance events. So what I do here is I want developers to not have to deal with strings ever, if I can avoid it. And we use Firebase performance tracking. Firebase is not very good. Firebase only supports strings arrays. So you have string to string array, like dictionaries really. So because of that, I don't actually want the developers in my teams to interact with the Firebase API at all, because I'm hoping we can one day get rid of Firebase. But the other thing I want is I want a very simple way to define new events and to use those events using typed manner. So the only thing that developers have to do is they have to add cases to enums, cases with associated values. So we have this public enum app event, and it conforms to auto event convertible. And then you can create as many cases as you want with as many variables as you want, associated variables. And then the other thing is you can generate child enumerations inside of the type. So you can do app event, then you can do section front, then you can do articles, and you can nest them, or you can have them as siblings, up to you. What happens is Sorcery will read this code and generate all the boilerplate for you. All the string matching, all the API to extract the parameters into the Firebase compatible dictionaries, which is just strings. And that's all. The only thing that developers have to do is they decide, okay, I want to nest this under a specific child enum. So then when they track this in the application, they can just do begin event, app event.sectionFront.item size. and they can nest as long as they want. So very convenient to use, very simple. And again, this is really simple to create. Basically, just iterating over the types implementing auto event convertible. I'm going to define a function because I want to have recursion for the chain support. I'm just going to do a very simple example here. So basically, the name is just extracting the name without the associated values. So this is the simpler one. Getting the arguments is a little more complicated, so I'm not going to get over that. I'm just going to show you the output. I'll put this online so you can see the actual template. But with AST, you can access your enumerations. You can access the associated values in that enumeration, their names, their types. So you can basically do whatever the hell you want. People use this for like moving from the associated values into pure functions, because there is a way, like for example, if you have the associated values, but it didn't have the default. You cannot have a default value for one of your associated variables, but you can create a static function on your enumeration that has the same name as the associated case that actually has the default values, right? And that can create the actual enumeration case. So there are ways to get a nicer DSL. But as you can see, like my biggest thing here is it's very simple to see the results. It's very simple to make templates that are suited for your project, not for just auto equality or hashing, which everyone can use, but just find cases in your project that have boilerplate. So this is how I generate the parameters, which is again accessing the associated values, then extracting them into a local variable called content, and then whether we have more than one, they just access the specific name for that content. It's really, really simple. The other thing that we have is A/B tests. So this, again, we use Abra, which is our custom A/B provider, but we used to use Firebase. And the way you used to define A/B tests was, again, using string APIs, which is just annoying and very error-prone. Now with Sorcery, what we can do is we can define a new variable on the structure that we have in the project called A/B test. And the only thing when you want to add a new test is to do the new variable, specify the enumeration that that variable is bound to. Enumeration just basically means all the variants that your application supports. So if I have A/B test for the config source, I can either use production config source or staging, right? So I just define a new enum, and then I just define this simple variable. And this is all that the developer has to do. Now, Sorcery has a template that works on a single type, not even a protocol. It just works on this type called A/B tests. And what it does, it generates a couple hundred lines of code that parse data coming from our providers, converts it into the actual values in the A/B test variable, and it also generates all the UI required to view those values, but also override them. So whereas a developer has to just define an enum, add a single variable, and they have access to view, modify, and parse that information done by Sorcery. They don't have to do anything else. So this is trivial. This makes it very easy for New York Times to run hundreds of A/B tests for different developers, different products, which is very convenient. The other thing that people can use Sorcery for is type erasure, which you have to do if you want to use protocols, right? Associated protocols. So if you have this protocol called Pokemon, and you have associated type called Pokemon type, if you wanted to store this into an array, then you have to do type erasure, and you can just write a template that generates all this code very simply. I'm not gonna put it in, but yeah, it's there's a lot of common cases in every project that you can use Sorcery for. And Sorcery is also bundled with a lot of generic templates. The standard equality, hashing, enum cases count. The benefit over the one provided by Apple is that you can use those skip persistence, skip equality annotations. So the moment you have a custom one, you can use auto equality instead of the derived one. You can generate mocks and lenses. You can generate advanced codable extensions. So codable is still pretty limited. If you have a custom sub-objects in your JSON, then you have to play to write a lot of code really to use codable, or you have to write it by hand. The moment you have to write it by hand, you open the door for all the problems that came before the automatic implementations. So better to use our template if you need to do that, because it still uses codable, but it generates all the boilerplate for you and it maintains it for you, which is the bigger deal. We have property level diffing, which is very convenient. I'm going to show it in a second. And a lot of people at Apple used it for Linux main because you actually have to define all the tests that your project has for Linux to work. So no point in doing that by hand. So for anyone doing tests, this is what Xcode thinks you should get as a result of failed equality. I disagree, because this is basically comparing, I have composed objects, and I'm comparing two articles here, and being able to actually understand what the hell is wrong would be convenient. Instead, Xcode likes to print the first article and the second article, and now deal with it. This is not very convenient. So one of the bundle templates is property level diffing. So you go from this to this. This is kind of easier to read, right? Easier to understand what is wrong in the article or in the whatever object you use. So this is much more convenient. And this template I wrote for Sorcery, and I think it was like 40 lines of code to get it to work. And Sorcery actually generates its own boilerplate, generates a couple thousand lines of code. So Sorcery generates itself, which is interesting, but it works very well. And the other popular template that we have is automockable. So for each function that you have in your protocol, Sorcery will generate function calls, so you can check whether the function was actually called. Received arguments, so you can verify what was provided to that function. A closure that you can inject to have side effects whenever that function gets called, and return value if you want to return something from a function. So very simple template. But this actually works for like 99% of use cases for tests. If you want something more powerful, people are actually building tools on top of Sorcery. One of those tools is SwiftlyMocky, which is also written by Polish guys. And it uses Sorcery to generate all the boilerplate to have a much nicer DSL for testing. So if you use OSE Mockito or one of those Objective-C tools that relied on a lot of runtime, it had this kind of interface when you could do given something, it should verify that this function was called. So they basically replicated that kind of very similarly in a more Swifty way. And this is all powered by Sorcery. It would not be possible without metaprogramming. So very simple to use, very nice, and also Polish, so that's great. There are also commercial tools that use Sorcery. So for example, ObjectBox is a multi-platform storage or persistence tool that is way faster than Realm is, which is something. So much faster than Realm and Core Data. It also uses Sorcery to generate its own, boilerplate generation, which is very nice because you can see as the example, when you want to use ObjectBox, you just declare a type conforming to a protocol, entity, and then you just use normal variables. You can just use strings, not very fancy things like in Realm. Realm is a little weird, and that's all you do. And what they do using Sorcery, they generate a query language for you, so you can do things like find every person that starts with Steve using typed API. There's no strings involved other than actual Steve. And so this is very cool, very very fast. You should check it out. Sorcery is available on GitHub. There's so many releases I lost count, but it's probably like 70 releases and 90 contributors already. So I actually very rarely modify the code anymore. There's a lot of people maintaining this because it's used in so many projects. We can eliminate boilerplate. You can write it once, test it once, which reminds me of a story. A friend of mine was in an Australian conference, and he was speaking with someone that said they use Sorcery, the specific person, not the company. And what was interesting, the way that person used Sorcery was for tests. So he wrote a template to generate unit tests and didn't tell anyone in the company that he's actually using Sorcery. So every time they have a ticket to write tests for a specific component, he would just run Sorcery template against the code and call it a day. Smart. The biggest thing for me when I was creating Sorcery was to limit human mistakes. So all the derived equalities are great when you can use it. If you cannot use it, then you have to maintain it by hand. And humans are very fragile and not very reliable. So I trust machines much more. So I would recommend using automation whenever possible. And that makes maintenance costs much easier, which is very simple. And for a more in-depth, like, I showed you a couple of templates, but I don't believe that presentations are very good at learning coding. It's good for introducing you to ideas or possibilities, but it's not very, you cannot actually modify it and see the results. So I built a workshop that you can go over multiple templates to create, including some of the ones I showed you, step by step. And this repository contains a wiki, and each step has its own commit, so you can just download this, play with it actually in real time, read all the information, learn how to create functions, macros, and all the stuff needed for your templates. And I can bet a beer that you'll find some code in your project that is boilerplate and could be automated. And if you don't trust me, there are a lot of people that like Sorcery. Yeah, thank you. And if you have a question, thank you.
I have a question.
Sure.
Is it possible to use Sorcery for different language landscape, for example, Kotlin?
Not really, because it relies on SourceKit. So if SourceKit doesn't give us the artifacts, we wouldn't really know what we're reading. There's a way to use Sorcery for Objective-C, though, because there is a tool that basically what Apple does, right? When you have Objective-C, you can see the generated interface. So there's also someone did a script that does that for your files, because they wanted to use Sorcery for Objective-C because they had a big code base with Objective-C. So you can run their script before you run Sorcery, and then you actually generate Swift from Objective-C, but not other languages. Yeah. You can very, like the things that are extensible in a very easy manner is the templating languages. If you wanted to add a new templating language to Sorcery, it would be like a matter of a day, since it's all modularized. And Sorcery is also a framework, so you can build commercial tools on top of Sorcery now. You don't actually have to use the executable. You can actually load Sorcery as a dependency. Although most people wouldn't integrate it like that, right? Like if you build a commercial tool, you probably had an executable, like Objectbox, for example. They basically have a custom fork of Sorcery. They have some additions. They changed some naming. They didn't contribute back. I'm like, yeah. Any other questions?
So when you created Sorcery, it was back at a time when Swift had no dynamic features, right? It was a very static language, very typeset language.
Mm-hmm.
And these days we're seeing a lot more dynamic features in Swift, such as dynamic member lookup.
Mm-hmm.
Do you see this impacting Sorcery? You're trying to keep as separate from it as possible?
I think the use case is a little different. It's true we are getting a lot of nice features. Some of the templates that people were using could be replaced. But like I said, until we get the, like Rust has the macros, but not C macros, like AST aware macros. Until we get that, this will be relevant. When we get the macros, probably not as much, but like dynamic member lookup, key paths, those are the two most common used. So you can do a lot of stuff with that, but a lot of this stuff that we use Sorcery for at the Times or other projects I am involved in doesn't actually fit those specific features. They're really nice for like bridging like Python, right? That's why they created it, I think, originally. Yeah. So, and I love key paths. Very powerful. You can do a lot of stuff. They use I don't know if you guys use Swift UI environment variables, but they actually support key path accessors. So you can define the environment variable that is actually accessing just a sub-object from your environment property using key paths. So it's very convenient, very cool. Doesn't really fit the requirements. So the derived implementations, they definitely based it on Sorcery. They saw the need because I spoke with people at Apple, and it's all cool until you run into that issue where you don't actually fit the 95% case, which for us is actually quite common because I use a lot of intermediate values that I don't want to persist. I don't want to compare because those are some artifacts. But yeah, I mean, the nice thing about this is a lot of people don't want to learn those new languages like Stencil. Learning Stencil is like 2 hours. If you run my workshop, you will be good to go for your projects. Like, I don't think you'll need to read more than the sorcery documentation for the ASD to build custom templates. And this is where the power comes from, right? A lot of people only use sorcery for the auto-equality, hashing. So when those things came out from Apple, a lot of people started using the Apple ones, and we did as well, right? Which makes total sense. Like, I want them to share all of this. I want ASD-aware macros. That makes sense for me. But there's so much stuff that is specific to your projects that is boilerplate. Just because this is a strongly typed language, and you have different types that are doing kind of the same things, the same patterns, and this is where the power comes in. You just invest a little bit of time to learn Stencil or AJS or the Swift templates. That's, in theory, that should be the easiest, but I really think that Stencil is better just because it gives you faster results and it's much more efficient. And so getting your project and seeing what is the actual boilerplate and then just attacking it with templates, I think that's where the value comes in. So until we get macros with AST, I don't see that happening. The nice thing about this is as well, you can debug this code, right? You can debug the code that generates because this is real Swift code that you have in your project. The compiler doesn't know that this is generated by the machine, right? I wonder how, if they, like, I know they will implement macros for AST because I spoke with Joe Groff about it when I originally did sorcery, and that is definitely on their agenda. Now, the thing is, how will they implement the tooling so we can understand what is happening if your macros are wrong, right? That was the biggest issue with C-level macros, that the moment you hit the bugger in it, like, it actually you couldn't debug it very easily, right? It was very, very complicated. So as we know, Xcode is not very good. So how they will solve it, I'm very interested to see. If anyone has any more questions, I'm going to stay here for a while, so you can just reach me. Thank you.
Thank you, Krzysztof. And now we have a 5-minute break, and we will switch computers, and you can grab a beer, go to the restroom.
Anyway, we have everything ready, so let me invite on our virtual stage Janek Mazurczak.
Hi, thank you for having me. So my goal today here is to create endless cities. So city you can go through endlessly for entire life, and it will never end. So I've created my playground where I'm asking for the building at the specific point, and I can fly like this through the city, and it works that way that it shows where camera moves. Do you see how it's loading near to the edge? And when you go further or back, the buildings are created. And here is how it works. For now, I'm just having some values hard-coded, like height of the building. So what can I do to make the city some more vibrant? I can random those values here, like this. Oops, sorry about that. And I have randomized height of the buildings. So I prepared a playground where I made all the characteristics of the buildings randomized, like color and filling the space in the block. And I got this. And I can go as far as I want, because those buildings will be generated and randomized at the specific position. But where the problem is? The problem is that random is different each time, right? So see that black building over here? When I go further and it's getting released, and I'm getting back there, there's no black building anymore. Because it's random, so it's always different. Remember this state? I'm going a little further and going back, and these buildings are different. So how to solve this problem? Let's imagine random numbers as a stack of numbers. So I have this stack, and I can get values from it. So I get some numbers, and based on those numbers, I generate my buildings, right? But my goal here is to get the same numbers based on the position of the building. So the encrypting algorithms come with help here. So for instance, SHA-256 is the one I will be using. And what this algorithm does, when we have some input and we treat it with this algorithm, we get some output we can't really predict, and we cannot get back the input value from the output. So the output will be something more or less random to us. But the trick is that having the same input, we will always get the same output. So because this part is some data, we can transform this into numbers, and we can transform this into stack of numbers. So I can get this, and I can get these kind of random numbers from this data. What it gives me is that if, as input, I use coordinates of the building, and I treat it as input data, it will be always the same at the same spot in my endless city. So transforming this with encryption algorithm into data, I will get always the same stack of numbers I can use to generate buildings, right? So sometimes this can be too short. I mean, this is limited number of numbers of values I can get from this. So what to do then? Well, to input data, you can just add 1 or 2 or 3 and so on. And the encryption algorithm is that funny that if you change one character in the input data, the output data will be completely different. It's because it's frequently used on the databases to store your passwords. Passwords are hashed, So this part is stored in the database. So, well, it should be. So the owner of the database cannot know your real password, only this hashed part, because you can't go the other way around. You can't get input data from this. And if you change one character in your password, the hash is completely different. So you can't really compare this to find out if your password is similar to somebody's else or something like this. But having this in our city generation gives us that if I add something to the input, I get completely different output. So I can treat this as a continuation of the stack, and I can get more numbers. Just adding a character to the input data, I can generate more and more these values. So how it works. When I jump to the code where instead of random values, I read the seed. I call it seed because this is something which can grow into something else. So if I keep the order of those readings and I use the same input value, which in my case is coordinates of the building plus some emoji in this case, but it can be anything. If you change this, your entire city will change. But still, at one spot, it will be always the same because those generated values will be always the same depending on the coordinates of the area. And it looks like this. So this is pretty much the same, right? But pink, red. I go forward, they're getting released, and I go back, still there. The same buildings. And it's pretty amazing when you know that you can go anywhere. It's definitely bigger than New York City, I think. So yeah, I like doing this Spider-Man thingy. And yeah, but this green building disappearing depending on the movement of the camera, but it's still here. Yeah? And it will be for everybody in the world going into the same location using the same input seed, so these values. So where's the problem here? This city is kind of chaotic. Did you see the Joker movie? Yes, so some people like chaos. But let's make this city more organized, right? So how to achieve this? I want districts, which differs, and I want some neighborhoods, which differs. To achieve that, I wanted to create something more than stack of random values. Let's take this and call it a seed, as it is in the source code. And this seed I'm getting, and I'm having this here. And let's have another seed, but let's imagine that here are those building areas. So these two are distanced more than one building. And instead of creating a seed for every single spot, I create only two. As a matter of fact, I create 4. And I create multi-dimensional space where when I need this value, I get these 4 seeds, get to the specific value at each of them, and I mix them to get value at this point. So I have something which is fluently changing when we move, and I can define these. Yeah, I am chaotic, and it can grow as well into infinity, because each seed has some coordinates, and I can get values in between, which will be not chaotic, will be somehow relying on those values around. Only these 4 in this case. Of course, you can get it further, right? You can add another dimension, but it's not for today. Our city has like 1 level for now. So let's see how it looks. In the creator of this building, I've created, instead of 1 seed, I created 3. 2 multi-dimensional seeds, with one is district seed and the other is neighborhood seed. And I've defined slice length, which in this case is number of these dots. See? So districts are 50 by 50, and neighborhood is 7 by 7, but it can be, of course, different as you wish. Remember that changing any of these rules will probably break the entire city. So the city will be completely different because it will use different coordinates for those points defining some dimension. And the 3rd seed is regular seed for 1 building. And that's it. So and then, for instance, height of the building is indeed district seed. I read one value, I multiply by something. Earlier, I generated a Boolean defining if a specific building is high, and chances for higher building were getting from neighborhood seed. So neighborhood defines how much chance you've got for higher building. So it will keep that city organized, because neighborhood has got like 7 buildings in 1 slice. This chance can change with 1 neighborhood and fluently go into another values. So if a building is high, I add some value. Also, I get this value from neighborhood, reading that seed, so more or less random values. And I read and I add some or multiply with a specific value for the specific building, which also can be different. So these algorithms here are up to you. So you can construct the city as you wish, but you can't really define like a specific place in the city, because it's endless. So it's impossible. With the color, it's the same. I get district color for each red, green, blue. I get district. Then I add some from the neighborhood, And I add something little more from the specific building to differentiate this. And it looks like this. See? So it's more or less better organization than before, correct? This is St. Paul neighborhood. This is some kind of Wall Street. This is very green neighborhood, and so on. So I was thinking, if I have district, and district defines something bigger, and I want performance in my app or game, I can pre-generate something roughly defining the district, which is farther and is cheaper to create because it will be like one box with rough height of the buildings around there. And because I don't need to calculate all those values for the specific building, I can get those nodes generated faster. And I've also prepared that. So let's see. This part is the same. Seeds are the same. But this is different because I get information if I have detailed node of one building, or I have some more distanced nodes, and then I use only district and neighborhood, and I don't add any specific values from the specific building for this. Instead, I let this box to extend to the entire area. Let's look. And you have this. I don't know, I have music here, but I think, yeah. Yeah, that's good.
So,
See that those distanced areas and how they become more detailed? Yeah, because I get those values from the district, then I can predict more or less what will be there without generating all these buildings randomly, which will be more expensive, right? Yeah, I was doing this entire week. With fire?
Yeah, fine.
Yeah, that's chaotic. Yeah. Yeah, so that's it. Thank you. Questions?
Are you using this SHI function each time you get a random value?
Come again?
I mean, you're using SHI, right?
Yes, yes, yeah.
To generate values
Yes.
given some input.
Yeah.
Do you use this very often? Like.
Yes, for each building, there is one seed created. So I use it at least once to generate some number of values on the stack, and then when I need more, the next, let's call it, page of values is generated, which gets one more SHA pass to get to the next page. So depending on the number of values I need for the specific building, yeah.
Okay, so as a follow-up, isn't like this a bit costly performance-wise? Do maybe some like cache this or?
Well, of course, it's somehow costly, yeah. But so of course it's not optimized here, and you'll probably pre-generate some part of the city where you are at the moment, and then pre-generate the other one. But then you can get rid of the first one and regenerate it when needed. Yeah. Something more? Nothing? Okay, I'll be here. If you were interested more in procedurally generated worlds with some depressed, slightly passive-aggressive commentary, please follow me on Twitter. And yeah, thank you very much. Thank you. Yeah, let's party.
We have pizza already in the kitchen, so enjoy.